That's kind of dead.
Yeah, I believe it was dead.
Well, I was going to ask you actually. What should I call you? Funny? Okay, R Funny.
Sure.
All right, Mr. Funny. Do you have you claimed that you've measured Earth curve? Because I know you said you've done surveying.
Yeah.
That sounded like a yeah and a no. That's a yes?
Yeah.
How have you measured it? And if so, could you give people here the way that you did it so then they could go replicate it if you think you measured it?
Oh, using tools like Total Station. The
Okay.
GNS receiver also.
Yeah, so explain it if you don't mind, or if you want to.
I turn on the machine and it connects to the internet, and then it searches for satellites and it tracks them, and then it also needs a base reference station. And it calculates angle elevation positions to the satellites while it's tracking them, and using the geoid 18 and the ellipsoid model, and then it measures an orthometric measurement, and that gives me an elevation based on Earth's curvature. Hello? Is it my internet?
No, you're good. I heard what you said.
Okay.
So would you say that's a first order measurement or like tangible measurement, or is it more of a calculation based on the equipment? Like the
It's definitely calculated by the equipment, yeah.
yeah. Is there any way in your mind they could program that to calculate it when it's actually not there, and to pump that out even though it's the curvature is not there?
Yeah, I'm sure there's a way to do that.
Okay, so would you say with that method that you're sure you measured Earth curve, or you just have some kind of level of trust or confidence that it's doing everything that it claims to?
Yeah, definitely a certain level of trust and confidence.
Are you licensed surveyor, or do you just do it like for work? Or?
I'm going for my license. It's a long process.
Have you ever created a horizontal plane of reference and then compared that to like water or the ground actually curving?
No, I've never done that experiment.
I have a genuine question for a surveyor.
Go on. Again, not licensed yet, but go on.
Yeah, no, but obviously you've dealt with dry rot.
Dry rot?
Yeah. In say like a house, it's had a leak, there's water ingress, and then obviously it's dried, and then obviously the spores come, and you get the dry rot. I don't know if you've seen dry rot.
I mean, I've seen like dilapidated houses, so like maybe you're just like, I know what you're talking about, but I just don't call like a wood that's a rotted house. Yeah, I've seen a rotted house before.
Yeah, it's not that the wood is rotted, it's actually spores. So you've got the mycelium and then you have the fruit and body. So even though the wood is dead, it can still, like have an effect. Because
Okay.
I've just been speaking to a surveyor and he told me that it can pass through brickwork. I asked him how, and he sort of like just said, it just does. We don't know, but it does. It sounded
I mean,
like,
I don't know what that has to do with the field of surveying, but okay.
yeah, they've come in, they've surveyed the house because we've got, they're saying that it's dry rot, so it's kind of a bit questionable. So he just said like dry rot can pass through brickwork, and I thought, oh, I've
I
never
just don't know what
known.
that has to do with the location of the house and its relation to the property lines.
Isn't that a completely different type of surveying, Slitsy?
Yeah, I don't know what kind of surveyor. That's why I didn't. Yeah, I just thought he was a surveyor. I didn't know what kind. If there's a difference.
No, he's a land surveyor.
Oh, I got you. Just property lines. Okay, no worries. That's why you're a bit miffed. Okay, yeah, different, totally different. Sorry for the confusion. But wouldn't you find that kind of a bit hard to believe that a mushroom can pass through brickwork?
You're just changing the subject now.
Just wondered if anyone could verify or deny it, or confirm it, confirm or deny.
Are funny. You were saying that. Oh wait, isn't your name Duncan? Do you go by Duncan or?
I haven't gone by like.
Well, I
No.
don't wanna-
Well, first of all, my name is not Duncan. I did used to go by Duncan, but that was like when I first started Discord, like I don't know, almost like 2 years ago.
Well, okay. I just remembered that was your name then.
I mean, you got a long memory, buddy. That's pretty impressive.
So I mean, with the surveying, so you think it's possible that all the surveyors could basically think that they're measuring Earth curve with the equipment, but the Earth not actually be curved? You were saying that's possible just with like the satellites and the way that all the system is intertwined. Like you
Well,
could get.
I mean, if you're using a GNS receiver, it's automatic that the programming has Earth's curvature because it has a geoid and ellipsoid model that it's programmed into. And then when you're using like a conventional instrument, say you don't even set up a baseline with your GNS receiver, you just set up a baseline with your conventional instrument. You just bang in the nail and you call it random coordinates. Even the data collector itself, if you're keeping track of your vertical height on the rod, like you check off for Earth's curvature. So if you do like a long distance measurement at like 600 feet or whatever, it's gonna like have Earth's curvature calculated into it to keep the vertical height accurate.
All right.
Does it bother you you're not actually measuring any curvature though in reality?
No,
It's basically a pre-assumption.
well, it's just it doesn't like what your statement was. Does it bother you that you're not actually measuring Earth's curvature? Does that bother you? And it's no, because I am doing that. Like, are you saying am I upset that the data collector is programmed to calculate Earth's curvature into the measurements and like refraction also? Why would I be upset about that? Like, that just leads to more accurate results.
surveying distances.
It's not more accurate results. It's a pre-assumption. You know, you're using these atmospheric charts, and
So if the GNS receiver
assuming.
isn't accurate, how come when I use that receiver to set up a baseline and then use a conventional instrument, why do I get accurate backsides?
Because long distance observation, there are reasons why you will get deviation from the eye level, right? Flat earthers can account for that, but obviously
But
you guys
just-
say it's curvature.
He's not even looking at that.
but the GNS receiver, so I'm using one instrument and it's like how is it determining, how is it putting my location as to where that GNS receiver into a grid system? And when I set up my instrument, it accurate, like how does it do that? You explain to me how it does that. If not using satellites and a base reference station, what is it doing?
I mean, I'm not a surveyor. I don't know exactly how the GNS receiver works. But is this similar to? Are you doing geodetic surveying?
Yeah, it's geodetic surveying, but I'm just asking you, how does the instrument work? Like, where is it getting these coordinates from? How is it accurately measuring the distance in between these coordinates? Because when I set up an instrument, the same way, like as if I were to just do assumed coordinates and measure the distances between the nails, like it would give me the same distance between the nails. So it's two different systems. Like, how is it doing it?
Well, you've got you're using the ECEF coordinate system. Is that right?
I'm using state plane coordinate systems. So when I work on Long Island, it's you can look it up. It's zone 3104 in the CONUS for the U.S. CONUS.
Right.
That's
Okay.
a flat reference. That's a flat reference.
Yeah, but the thing is, it's a flat reference system, but it's for a very small area of the globe, which is why when I go just like outside of the boroughs of the city, I have to use New York East when I'm in the eastern area, and then when I go into the middle of New York State, I have to use New York Central, and then there's like another grid system so just New York alone has 4 different grid systems, because if you want to accurately represent like a flat grid system onto a spherical object, you need to break it up into multiple grids.
Well, that's why I asked you. Does it bother you that you're referencing a flat Earth in reality, and all of this is calculated in after?
He thinks
Like,
it proves
you're not
so
verifying. What I'm saying is, you're not verifying there's any like deviation in the zenith or your horizontal, your vertical. You're not actually confirming that, right? You're just using the grid system and you're
He's
pre-assuming
spoken
it.
on before.
Well,
He said-
I can, because I can take off like the correction for Earth curvature, and then I can do a really long distance measurement, and I can see when I do a horizontal backsite, I get a vertical error.
Yeah, but that's why I said earlier, long distance observations can be accounted. The deviation can be accounted for in a long distance observation by flat earthers.
Yeah, but I'm accounting for refraction already. So what else do I need to account for?
Well, just non-linear vision. Things converge and diverge in the distance.
Well, you're talking about perception, not actual measurement. Like, you're telling me that the instrument that's tracking the prism is perceiving, it has like its own mind where it's perceiving its thing, or is it just actually reading like an angle measurement and a distance measurement?
Yeah, it's taking an angle to the horizon and any distance, any dip.
No, we're not talking about the horizon. We're just talking about it's tracking the prism. It's not tracking the horizon. It's tracking the prism. I'm talking about doing a long range shot, like you bang one nail in, I put in another nail like 1,000 feet away. I don't check off for Earth's curvature, and then I keep refraction checked off, so I'm accounting for refraction. Like, how is it? The instrument's not perceiving. It doesn't have perception. It just measures stuff. So unless there's another variable that we're not accounting for, why would I get an error when I do a backside check? When I put the instrument on the point I shot and I go to the nail that the original one was on, why would I get a vertical error?
Are you talking about differences in topography?
No.
So how are you accounting for curvature then? How is this reading a curvature from
That's
your
the thing.
position?
That's the thing. In this example, I'm not accounting for Earth's curvature. I have that. I choose to check that off the machine. So it's not accounting for it in the program anymore.
I don't know. You're gonna have to give an example, because unless it's topography changes, then you're not verifying a drop over distance. And I know that they're using the coordinate system, the ECEF coordinate
You're not
system.
listening. So like, let's say for example, I bang in, like, I'm gonna do 3 nails, right? One's on top of a hill, and the other one's like down the hill, and the other one's further down the hill, right? So like you can see every nail, you can see every other nail. I set the instrument on top of the hill and I say it's at like 2,000 feet elevation. I'm just making it up. I'm doing assumed coordinates. So 2,000 feet, 5,000 by 5,000, right? And I cite the very far nail, the furthest nail. I cite that as north. I'm just making up coordinates. I'm just random. It's just random. And then I take a shot on it. It would automatically calculate that nail's elevation just based on.
Well, you're breaking. Is he breaking up for everybody or just me?
And I start.
Is that him roboting or is that my connection?
He's cutting out for me too. So
Yeah, it's him.
Gio, am I missing something? Do you know what he's trying to say while we wait for him? Or anybody?
Am I good now? I got 2 bars. Am I good now?
Yeah.
Yeah, I can hear.
3 bars. Sure, I should be good now. So yeah, if I'm up on top of a hill and I just make up an elevation for the nail, call it 2,000 feet, and I shoot a nail far away that's downhill, it automatically calculates an elevation for it based off the angle that the instrument's at. It automatically does that. So we're not talking about topography. We're talking about the given elevation. And when I do a check against that nail, if I set the instrument up on that nail and I shoot another nail, I'll get a larger vertical error if I don't have Earth's curvature correction checked off on the program.
Yeah, short distance. Yeah, you're just measuring the angle difference, right? I'm with you. Yeah.
But my point is, I have done that like experiment where I've set up 3 nails and I shoot the nails. One job has Earth's curvature and refraction checked off, and the other one has Earth's curvature. What? I don't know why you're laughing.
I feel like I addressed this earlier. Short distance is different to a long distance observation.
This measurement, the furthest distance, because there was 3 nails. The furthest distance between nail 1 and let's call like the further one nail 3, but it was really 2. The middle one was 3. Was 1,500 feet.
Right. Yeah. So you're able to measure the difference in angle. Okay. Yeah.
The point is, when I did the backside check on the third nail, when I had Earth's curvature correction checked off, I had less vertical error than than the job comparatively.
And that's because of Earth's curve.
Yes.
Over how long? Over how much distance?
The furthest distance between like nail 1 and nail 2, the midpoint was 3, was like 1,500 feet.
So you're getting a deviation of what? Do you remember?
It was a couple, it was tenths of a foot.
So, and you think this is valid Earth curve confirmation?
Not confirmation, just evidence towards the fact.
But dude, it's so random. You can there's so many variances, there's so many reasons why there might be deviation. I mean, you're on a hill, for example, for one. You're on a rough
Well,
terrain.
I was on the side of the I was on a side of a highway. The example I brought up on a hill was just to explain to you that the machine calculates the other nail's elevation based off the angle. But when I did this thing, I was on a side of a highway. It was relatively flat.
So I have a question. Are these direct line of sight nails? And why
Yeah.
wouldn't the machine just calculate the elevation based on where the nail is? Why would the setting change anything if it's direct line of sight? I'm sorry, I've never done any geodetic surveying in my life, so
Well, this wasn't geodetic
I-
surveying. This was just with the conventional instrument doing it using assumed coordinates.
Because verticals on a globe are all different. So if your machine doesn't know you're on a globe and you got it set for flat, then as you move around the globe forward, it'll think that the machine is tilted rather than realizing that it's on a curved surface. And that's what he's talking about. If you turn that off, it doesn't realize he's on a curved surface, so it thinks that the machine is just tilted and it's not level correctly. But if you set it to where
I would say the machine I don't think the machine thinks. I'm sorry to interrupt. The machine doesn't think it's tilted. It thinks you're tilted. Just a quick, because the machine thinks it's level always. Otherwise, I would like the.
Well, okay, I might have a little bit wrong. But you get
I'm being a little pedantic. Sometimes these guys, will nitpick every little thing. So I just want to be clear. The machine doesn't think it's not level anymore. But this is just two different ways where it's the same nail, same distance apart. One of the times I have the data collector programmed to calculate for Earth's curvature. The other time I don't. They're both checked off for refraction. They're both done at the same time, relatively, like within 15 minutes of each other. Why would I get a bigger vertical error when I don't have Earth's curvature checked off?
Did you get this argument from ChatGPT?
No, I mean, I literally have, I can show you pictures of me doing this if you really don't believe me.
When you say a bigger vertical error,
You don't.
you're saying it has a vertical error.
I do have pictures. Well, hang on. I got to address this because, he's saying I don't have the pictures. So if someone wants to
you're
give
just
me
fucking lying.
permission, if someone wants to give me permissions to post pictures, I can literally post the pictures of me doing it on the side of the highway with the instrument reading the distance measurements of the furthest nail.
Yeah, I've heard the instrument in the background while he's got his mic open. We've heard his computer.
So you got a picture of a nail on the ground?
I have a picture of
That's the
me.
evidence, you fucking retard.
I literally have a picture of the data collector reading the distance, and then I took the camera up and I brought it up to the machine, to the zoom thing, where you can see the prism rod all the way down the thing, all the way down like the. So yeah,
Do you
I
have
can
a
literally
video, or is
post
this a
those
slide?
pictures.
Do I have to watch a
I
slideshow?
can. Yeah, you're upset now because you actually realize that I do have these pictures of me doing this.
Oh, I'm not
So
upset.
yeah, you are.
You're just lying
clearly
about.
because
It's funny.
you're
You're
shifting the
fucking lying
goalpost
about
now.
pictures of nails
I'm
in the
not
ground.
lying.
Okay,
I'm not lying.
prove it then.
Give me permission to post pictures in this chat, and I'll do it right now.
Yeah, sure.
Yeah, sure, I will.
I didn't even know you were talking about a real nail.
Yeah, I gave you the role if you want to post them, but I mean, we were kind of having a more productive. You don't have to do whatever if you don't want to post stuff about yourself or whatever.
Yo, silly.
Not really.
I mean, funny, whatever. When you say you have a bigger vertical error,
Like, sounds like Bob hasn't had his morning coffee, so.
I haven't.
his morning raw milk, his sipping raw milk sipping in the morning.
funny. It sounds like you're saying there's always a vertical error in any setup.
Yeah, of course, there's always going to be a vertical error, but the point is that I'm using I have the instrument set up, and I can. When you have the data collector, you can basically change out the job. So I created one job with Earth's curvature correction checked off, and I had another job. So like with the instrument set up on the nail, I literally just changed into one job into the next and shot the two other nails. It's literally was a time difference of me only going back like from the nail 2 to nail 3, then back to nail 2, changing into the job, shooting that nail, and then shooting nail 3.
Right. Look, I'm more wanting you to just teach me this thing I don't know. I'm not challenging you. Why do you have a vertical error always?
Why is there a vertical? Because like there's always going to be either slight human error. There's going to be like the refraction's not calculated perfectly. There's always going to be some like variable that affects it. The point is, the more accurate one was when I had one of the variables being Earth's curvature calculated into the measurement. So all things being equal, the more accurate one was the one where I had Earth curvature correction checked off.
What if there's some unknown element, some extra refraction that happens to be Earth curve ratio? Like,
I don't know what you mean by that.
what if light?
Like I said, the only variable that changed between the two jobs was one I had Earth curvature correction checked off, the other I didn't. All other variables were left exactly the same, except for the time difference of about 10 minutes from me switching over from one job to the next. So, like, if you want to say there was some crazy change in the temperature in that 10 minutes or humidity or something else that somehow made like the one job like more,
That's not
like
what I'm
that's
saying.
the only thing that could have happened.
I'm more like this, man. Like, you know, some you know, gateway flatter topics can be like, look, the boat's over the horizon, blah blah blah, it's flat, and then the Globers will be like, no, look, the water over the ocean is cut off at a crisp horizon line, so there's the curvature. But what if there's just an element to vision to light where it just does that, right? Would this tool help falsify that in any way? You know, like, what else are you doing besides just the same thing everybody's doing anyway, just more precisely? Like, you don't have to have that type of instrument to really see drop. They do it with just a camera, you know. They don't even. So I guess I'm saying, what can you do if you're shooting forward and backwards and all this? What can you do to just be like, oh, I know it's not a optical illusion? You know, how do you actually know the hard ground has dropped under you?
Again, optical illusion deals with perception. So, like, how is the machine being like it? I'm just confused by that. We're talking about a machine that's reading angles, and then we're only talking about changing the one variable of the programming. So I don't understand how any other illusion would change the results. I don't see how that's relevant.
I got you. Things in the distance seem to drop in. You're just adding more precise stuff to the stuff that people kind of already witness, even with their plain eyes. But
See, Press,
yeah,
like it seems like you just said to you the Earth seems spherical because things seem to be dropping off in the distance.
everybody.
So to you, the Earth looks spherical.
No, see, this is too micro. It's the same thing where you talk about you got a little tiny area. You know, it's too tiny of an area for me to just be like, oh, you know, it's got to
But
be a
you're
sphere
saying,
because of the vision. You know what I'm saying? It's vision. It's light. There's all this unknown stuff about that. I mean, I like how you're saying, oh, I need these local maps to use flat plates, and basically, it's like if you put a bunch of little plates on top of a basketball or something, you know, you're going to be off if you're not using the right plate. If you're not right, it's going to pretend you're tilted rather than flat. You know, I've liked when you
right?
talk
So,
about stuff like that more, but how do you know they're not just programming that in there? You know, it's like the
well,
program.
it is programmed in. It is part of the programming. But the
How do you
fact
know that's
is,
not fucking
so
above
like for example, you brought up the basketball and the plate things. Now, if you had like a actual like standard sized basketball, right, and then you had 5 like 4-inch 4x4 plates or whatever, and you like I don't know if that's the accurate or 10 or 15, whatever it is, and you tried to place it on the basketball so they all think there would be bigger gaps. Now, if you had 100 like 1-inch plates or whatever, you could like fill in those gaps a little bit more. And if you had 1,000 like 10th-inch plates or whatever, you could actually like get really really close and fill in the gaps more. And that's the whole point of the grid system is that you need multiple grids to cover the spherical Earth because that's how it works. Like you need these tiny grids
Okay, yeah, but
for the
listen,
Earth.
if anybody like a dumbass like me can understand to that depth of the issue, right? Well, plenty of people can understand that little picture, but and logic. But when you're talking about now there's a program that if we use this, if we tell we're tilted over here in this way, but we're over here, the program doesn't work. Like for the average person, we're not going to be able to understand what that program is doing, and what false positives it can be giving you as far as your tilt zone of the Earth or whatever, your different zone on the basketball, right?
So
So you know how to break that down, like programming.
So the way you get rid of false positives, because they do occur. So for example, like just yesterday on a job, I had a fix on a nail. And when I shot it, and I always do a couple shots on it just to make sure, the next time I shot it, even though I had 2 fixed positions, would say I was within like less than 1/10 of a foot, both horizontal and vertically, it said I was like 6 feet away and 4 feet higher. So I stored it as another point. And then I took shots on it again, and like it was getting closer to that second area. And when I set up and I checked into one nail, I used the one version and I got a huge error. And then when I used the second version of the nail, I got a correct error. So false positives do exist, but that's why we do backsites to check into them, to check into another nail to get rid of those false positives.
About a correct error though, and again, you use these things because you want to use some form of GPS or whatever you call GNS. So I guess why even use that at all? Why not just turn that shit off and just use it raw?
Well,
The machine
because
is flat. Like, what do you need that shit for?
so for example, one of the things we need it for is for locations of flood zones and areas. So we need to know like, oh, this area sits where all the water will flow into this area, so that can be a designated flood zone. So we need to keep track of accurate elevations for that for insurance reasons. That's why when you do like a FEMA flood certificate, they won't take it unless you're using Nat 83 like or later.
Man,
I'm
it's like
still
I get
waiting
it.
on these pictures that you don't have.
Well, I'm driving right now, but I'll get to my
Of course.
first job in 2 minutes. I'll get to my first job in 2 minutes, buddy, and I'll post the pictures.
All right.
It's cool you get to work. You get to do the field work while you're still certified.
Well, there's a licensed surveyor that stamps the maps that I create.
Yeah, it's cool. I'm just saying it's cool, man. It's good for you.
Oh yeah.
I've had friends that done that. That've gone through the different programs here.
No, this is I got like 8.5 years experience now in the field. I had to I had to summarize all the different like years of my experience, how it attributes to it, submit that to a board to get approved just to take the first national test. And then if I pass that, I can take a second national test. And then if I pass that, I can start going to other states and taking the individual state exams. It's pretty crazy.
I mean, it only takes 5 years to train to take apart like a super Eagle on a Ford. They make you wait 8 years, or I guess you said the school was 4 years. Also, you just didn't get into it right away.
Well,
You said 8 years. I didn't know you've been in it that long.
in New York, I'm grandfathered in where I didn't need to go to an accredited school for the 4 years, but that's ends in 2029. But I'm grandfathered in.
OG surveyor. You're the last of the old school, man.
That's definitely
Real.
not true.
Keep it
That's
real for the
definitely not
flatters.
true.
There's gonna be a whole new wave of digital babies after you, man. They're gonna be indoctrinated with the 4-year plan and all that. I don't know what they. Man, look,
Because this guy here.
Are we getting pictures?
I just posted in the chat my newest Lego set that my kids bought me for my birthday coming up, and I think it's really cool. And it's actually mechanical. You flip it on and it spins around.
That's propaganda.
What about it is propaganda?
The globe in space.
What about my pictures? I thought you were talking about my pictures. Never mind. For refraction already, so what else do I need to account for?
Well, just non-linear vision.
I just posted in the chat my newest Lego set that my kids bought me for my birthday coming up, and I think it's really cool. It's actually mechanical. You flip it on, and it spins around.
That's propaganda.
What about it is propaganda?
It's a globe in space.
What about my pictures? I thought you were talking about my pictures. Never mind. The next. So, like, if you want to say there was some crazy change in the temperature in that 10 minutes or humidity or something else that somehow made like the one job like more, that's the only thing that could have happened.
I'm more like this, man. Like, some gateway flatter topics can be like, look, the boat's over the horizon, blah blah blah, it's flat, and then the Glovers will be like, no, look.
That you don't always get that. Maybe you do, but in reality, when you take long distance observations through an optic, you don't always get drop below the crosshair, the horizontal crosshair. You can get an object, a nail, that would appear above the crosshair.
Technically, I am measuring the drop because if the more accurate one was with Earth's curvature, which is accounting for the drop over distance, then technically I am measuring the drop.
So I am accurate by talking about drop over distance. Then now you're just
so yeah, but so then technically I correctly like the more accurate measurement of drop over distance was with Earth's curvature calculated.
Would you say you would get more accurate?
It accounts for the drop over the distance.
And would you get more accurate towards the drop of actual Earth curve radius of the longer the measurement or the shorter the measurement?
Well, the instrument has a range, so I can't like.
I'll repeat the question. Would you say the longer you measure a measurement, the accuracy of your measurement would closely relate to the Earth curve radius, or the shorter, the more accurate measurement that we all know measuring shorter would be more accurate? Would that more accurately match the Earth curve drop? You can answer. It's okay. We all know the answer.
If you measure like between like nails of like 50 feet, the difference is negligible. That's why like you do need a longer range to show the difference in accuracy.
I'll repeat the question so we can get a clear answer.
I thought I did answer it.
I'm going to give you another shot though, to be fair. If you measure nail to nail over a 1,500 feet and you get a drop rate, and you measure nail to nail over 15 miles and you get a drop rate, which one would more accurately match the radius of Earth drop?
I would imagine that the 15-mile one would be, but I don't know how you would be like. Are you talking about just doing a long range reciprocal zenith angle test? Because that's not the same thing as what I'm doing.
We can go with
Like
that answer, and I agree with you. And I'm going to make the statement that why I asked the question. This is the only thing that the longer the measurement, the more accurate it accounts for. It's ridiculous.
Why is that ridiculous?
Because in measuring things, hardly ever when you're talking about, unless you're talking about like, minuscule, like using a tape measure to measure millimeters. If you're measuring 100 feet or 1,000 feet, the 100 feet measurement is always going to be more accurate with these tools.
Let's just say like you had to measure like a 100-foot length object, right? Would you be able I'm giving you the length of it, but I'm not going to give you the actual length. It's roughly 100 feet. It's not exactly 100 feet, but it's when you look at it, you think, wow, that might be like 100 feet long. Who would be able to better accurately measure it? Someone with a ruler that only goes 1 foot and they can only measure the 1 foot and then guess it to like the rest of it, or someone with a 25-foot ruler where they can measure it like the 25 feet and they can see like, okay, well, this is this portion of it. Who do you think would be able to better guess?
The 25 foot. But that's not at all what we're going about.
But that's the longer measurement.
Yeah, but
How
you're
could
switching
why
the
would
tools
the longer measurement lead to a more accurate result?
because you switched the tools and you tried to fool the audience, but you didn't fool me.
Yep.
I mean, come on, man. You think we're dumb?
No,
Well, that's y'all's
I
biggest
think you
problem
guys
is
are
y'all think
silly,
we're
and I
dumb.
think you guys are funny. I
I
don't think
know
you
that's
guys
your
are dumb.
problem. I know that's your problem. That's why you mock and scoff, and that's why your name is Flat Earth Funny. Because you're a mocker. You're not out for the truth. It's weird. You admit it.
Well, the irony there is
You just said
early
that
night.
Sorry, Cuddles. Go ahead.
Well, the irony there in the early 1900s, the Globers are the ones that made up the term flat earther. It was actually a very, I think it was a famous Glober that actually coined the term.
Propaganda. It's propaganda. It's propaganda.
What about his propaganda?
The globe in space.
What about my pictures? I thought you were talking about my pictures. Never mind.
I can't even see the nail.
You see that little pink thing that's at the bottom of the prism rod in that second picture?
Yeah,
That's the ribbon around the nail.
it's pretty blurry. So there's a nail on the street.
Yeah, I just banged in a nail on the road. Exactly.
And it's tilted.
Is what tilted?
The nail.
What does that matter?
I'm just saying.
I mean, yeah, roads are curved so that the water goes to the right and left of them as you're driving. So the nail, because it was into the curb, like, yeah, sure, the nail was slightly tilted, but the center of it has a little hole where the prism rod has the point that goes into it, and the prism rod is level. So I'm a little confused as to what your point is.
You just said it's tilted.
But the rod is not tilted. I mean, if you want to say if it's level, if being level is tilted. I mean, it's not perfectly level because that's not a thing. That's not a real thing.
Well, how about this? Is it plumbed?
As like, yes, within a certain amount of accuracy, but like nothing is ever perfectly plumb.
I'm going to call BS on that.
You can always. Why is it BS?
Because if nothing's perfectly plumbed, then you don't even have a globe. If nothing can be perfect, then you don't have shit to start with anyway. You always are in the margin of error too. So it would end all the debates.
There are no perfect measurements.
I'm sorry, that's not a rebuttal or an answer to anything I said. So I'm confused.
It
But
is.
you always chime in.
Well,
with
what you said doesn't mean anything.
right, nothing is perfect. So then, how do you have an actual place to start to say anything about any part of reality? See,
Because you have
if it's all messed up and none of it's straight, none of it's perfect, none of it's organized in an orderly fashion, then measuring and all of this is going to be very difficult to do.
Because you have degrees of accuracy, and that's what you go off of. Degrees of accuracy and precision.
Precision is accuracy to 100% marker.
No, there's two different things.
There's precision to a finite point where you've got slop in there, and then there's precision to perfection.
So imagine you had a bullseye target and you had a machine automatically shooting off, and it never quite like hit the bullseye, but it always like circled around it. It always like that. If you took an average, like there was an average around. That is a relatively accurate, but it's not precise. That's the difference. And then if you had another gun where it kept shooting, and it kept hitting in the same exact area, but it was off the bullseye, that is a very precise instrument, but not accurate. That's the two different things.
Well, we're talking about
Understand
stuff
the difference?
attached to a stationary rock
No,
that you're standing on.
Before we go on to some other thing, do you understand the difference between accurate and precise?
I do. Which one do you think you have?
Both.
Yeah, but you think you always get dropped from the horizontal, and that's just not true. You're not telling the audience that.
What I told the audience was that when I set up an experiment of the instrument being on one nail, shooting nail number 2, and then shooting nail number 3, and having two different jobs. One job with earth curvature checked off in the programming of the data collector, and one without it. And I compared the two results. The more accurate result was the one where earth curvature was calculated for. That's what I told the audience.
Yeah, I heard you. But you're saying that both errors are below the crosshair, like you have drop in both, right? Just the more accurate one is the one with the earth curve switch on, which is kind of weird for a machine to have an earth curve switch because, you're on a curving earth. But anyway, we'll get to that another day. But
Well,
that's
how
just
can
not
one-
true. You don't always measure drop.
So both in both experiments, the instrument was both precise in both instruments. It was precise, but the less accurate one was the one where earth curvature wasn't calculated for. That was the less accurate
You're not getting my point.
but they were still precise. They were the same precision.
Yeah, let's go through it slower because you didn't get it the fast way. Did you measure drop both times?
It's not about measuring drop.
Yes, that's the whole entire argument of earth curve is measuring drop from horizontal.
No, there's
So
there's lots of different arguments. One of them
Okay.
being
This is
reciprocal
amazing.
zenith angles, which talks about thumb
Excess
being
angles of
different
triangles, but you don't get that with short.
and there's
accurate
also
measurements.
then you can also talk about spherical excess. That's another thing.
Which
There's
you don't
multiple
get
different
with short
arguments
accurate measurements.
besides
You
just
only get
drop
those
over
with
distance.
long- You only get those with long distance. I don't know why you're trying to switch. I asked a simple question. Did you get
I'm not
drop
trying to
in
switch.
both?
You're trying to switch.
No,
You're
I'm
trying
not.
to
I'm
switch
switching.
it to drop.
No, I'm
You're
not.
trying to switch it to drop over distance instead of just talking about accurate results versus less
You
I'm
added
accurate.
in the
talking about-
curvature drop, though. This is the
I'm
problem.
talking about
See, not
drop from nail to nail. You measure drop, and you're not telling the audience that you don't always get that. Maybe you do, but in reality, when you take long distance observations through an optic, you don't always get drop below the crosshair, the horizontal crosshair. You can get an object, a nail, that would appear above the crosshair.
Technically, I am measuring the drop because if the more accurate one was with Earth's curvature, which is accounting for the drop over distance, then technically I am measuring the drop.
So I am accurate by talking about drop over distance. Then now you're just
So yeah, but so then technically I correctly the more accurate measurement of drop over distance was with Earth's curvature calculated.
Would you say you would
Because
get more
it
accurate?
accounts for the drop over the distance.
And would you get more accurate towards the drop of actual Earth curve radius, the longer the measurement or the shorter the measurement?
Well, the instrument has a range, so I can't.
I'll repeat the question. Would you say the longer you measure a measurement, the accuracy of your measurement would closely relate to the Earth curve radius, or the shorter the more accurate measurement that we all know measuring shorter would be more accurate? Would that more accurately match the Earth curve drop? You can answer.
So
it.
if you measure between nails of 50 feet, the difference is negligible. That's why you do need a longer range to show the difference in accuracy.
I'll repeat the question so we can get a clear answer.
I thought I did answer it.
I'm going to give you another shot, though, to be fair. If you measure nail to nail over 1,500 feet and you get a drop rate, and you measure nail to nail over 15 miles and you get a drop rate, which one would more accurately match the radius of Earth drop?
I would imagine that the 15-mile one would be, but I don't know how you would be. Like, are you talking about just doing a long range reciprocal zenith angle test? Because that's not the
We can
same
go
thing
with
as
that
what I'm
answer.
doing.
We can go with that
Like,
answer, and I agree with you. And I'm going to make the statement that why I asked the question. This is the only thing that the longer the measurement, the more accurate it accounts for. It's ridiculous.
why is that ridiculous?
Because in measuring things, hardly ever when you're talking about, unless you're talking about like, minuscule, like using a tape measure to measure millimeters. If you're
So-
measuring 100 feet or 1,000 feet, the 100 feet measurement is always going to be more accurate with these tools.
Let's just say like you had to measure like a 100-foot length object, right? Would you be able I'm giving you the length of it, but I'm not going to give you the actual length. It's roughly 100 feet. It's not exactly 100 feet, but it's, when you look at it, you think, wow, that might be like 100 feet long. Who would be able to better accurately measure it? Someone with a ruler that only goes 1 foot and they can only measure the 1 foot and then guess it to like the rest of it, or someone with a 25-foot ruler where they can measure it like the 25 feet and they can see like, okay, well, this is this portion of it. Who do you think would be able to better guess?
The 25 foot. But
But
that's
that's
not
the
at all
longer.
what we're talking about.
But that's the longer measurement.
Yeah, but
How
you're
could
switching
why
the
would
tools
why would the longer measurement lead to a more accurate result?
because you switched the tools and you tried to fool the audience, but you didn't fool me.
Yep.
I mean, come on, man. You think we're dumb?
No,
Well, that's y'all's
I
biggest
think you
problem.
guys are
is y'all think
silly,
we're
and I
dumb.
think you guys are funny. I
I
don't think
know
you
that's
guys
your
are
problem.
dumb.
I know that's your problem. That's why you mock and scoff, and that's why your name is Flat Earth Funny. Because you're a mocker. You're not out for the truth. It's weird. You admit it.
Well, the irony
you
there
just-
is
You just said
early
that Sorry, Cuddles. Go ahead.
well, the irony there in the early 1900s, the Globers are the ones that made up the term flat earther. It was actually a very, I think it was a famous Glober that actually coined the term.
Well, what else would you call a person that thinks the Earth is flat?
Well, what do you call a disbeliever in your religion? I mean, do
I
you
don't
call
have a
them
religion.
anything? Do you really
I
have
don't
to
have
make
a
up a
reli-
name?
I don't have a religion.
Oh, okay, then why do I get preached at every day, hanging out with my friends?
You don't have any?
No, I don't have any religion that I belong to.
I don't believe that, bro.
That's the problem.
Nah. Because the globe is a religion.
I was raised Catholic. I got my confirmation and everything. I did communion and baptism and all that stuff. But I don't consider myself a Catholic anymore. I guess the church considers me still
You're a
Catholic.
globetard.
Well, hold on,
Cool.
guys, because
Okay,
I did change the
okay,
topic.
fine. I'm a globetard. If you want to call me a globetard, does that makes you feel better? By all means, do it.
I did want to bring clarification because not everyone knows where Flat Earther comes from. They think we gave ourselves this label, and no, that's not what happened. We, back in the day, said, hey, we don't believe in whatever you're spewing. Whatever you're selling, keep it. And that's where we got called Flat Earthers. Besides, it was used as an ad hominem. It still is used as an ad hominem, which diverts away from your whole point of trying to prove the globe in the first place. And by the way, I can't see the nail in that picture, so you might want to tell Jesse Path of whatever that they actually have a optical limit in range, because he thinks they can just go on forever.
Who thinks? Wait, what can go on forever?
Jesse, hold on. He's on another
What-
server and this one.
I know who you're talking about. Like, what does he think can go on forever?
The optical range, bro. You can just look through that on an infinite distance off and figure out where everything is, even though you can't rectify it.
Well, yeah, there is like as far as like seeing things like I can't think of a limit to like how far we can see.
I can. Every magnification
have a-
lens has a distance
If you have
limit.
if you have a large enough and bright enough object, I don't know what the limit would be for how far we can see that object.
Right. There is, because blimps.
What? Yeah.
Blimps is a
What's
perfect large example. They paint those blue
No,
and yellow, and the further away you
can
get
think of-
out of the city, it
I
disappears.
can think of an object. I can think of an object bigger than a blimp, though.
Yeah, and they still disappear. They all disappear.
Yes, because they're not infinitely big and infinitely bright. But as far as like, are you saying like within the physical world, there's a limit as to how far we can see? Yeah, the limit is like the distance from an object that's the biggest object it can be and the brightest it can be. But as
The
far
limit
as
is the-
logically, as far as logically possible, like if you can imagine an object infinitely bright and infinitely large, there's no limit to how far away that object would be where you couldn't see it.
But there's nothing like that. So now you're having to manufacture something that doesn't exist in manifest reality to say that, aha, my reality is this way because of the thing that doesn't exist. It's like, what?
Well, now, like, yeah, so now we can compare, like, well, what's the furthest we can see with the naked eye? There's a limitation to that based off of, like, your location, because you have light pollution if you live next to a city, so you won't be able to see as far. But if you live in, like, the middle of nowhere where there's no light pollution, you can see stars that are further away. If you use a telescope, you can see even further. You're still seeing things that are further away, like whether or not you use a machine or not.
This is why I use an auto level and meter stick. Because you guys can't lie to that device.
And we weren't getting, we were horizontal basically to the water. We thought we were going to get dropped because we were all Glovers. And when we didn't, we tried to figure out what we were doing wrong and then decided that we weren't doing anything wrong. And then when we went past the first mile, we started doing longer shots, 500 and 600 foot.
So you establish a new level. The furthest you established a level, like from like the distance was 500-600 feet. That's like the furthest, and then you had to establish a new level after that.
That was like in the third, after 2 miles. Like the first mile, we were 200 or 300 feet at a time.
So are you assuming that water is horizontal or you just assume it's horizontal?
I am now. It's either we're on a sphere and that local lake is horizontal, or it is horizontal, like we're not on a sphere, or we did something wrong.
I just don't
How
understand
far
why.
was your overall, if you don't mind? Because I got
What?
2.25. I got
You
like
said
2.25
2.7 miles.
I observed like
Well, the
no
total length was 2.7 miles, but the most accurate was the first mile. After we didn't get any elevation change from our benchmark over the first mile, and we thought we would. We didn't even know how much, like we were Glovers, but we didn't know the drop rate. But when we didn't get any drop, we went further and further to make it go quicker because it sucked. The time consumption, it took way longer than we ever thought it would, and wasn't fun. Like we thought it would be in water. We're on our local lake at our camp with jet skis and boats and all our tools that we use to make a living, and kind of not competing, but seeing who could be most accurate out of 3 groups with 3 different tools. You see what I'm saying? And it wasn't. It sucked. It was like a job. It was like we were working harder than we do on our jobs, and we weren't going to make money. And then the first mile, which we figured we were the most accurate, we didn't get any deviation from our benchmark of our horizontal plane. Then, we thought we did something wrong. Basically, we didn't give up. We kept going. We wanted to do 4 miles, but we just ran out of time.
That's pretty extensive.
Yeah. It's basically extending the straight line segment. Like if you take a ruler
Yeah, I
of a
get.
short, shorter, scale it down with a ruler, and you just draw a line, and then you extend the ruler out to the left or right using half the ruler to line up your line, and then extend that line with the other segment of the ruler. That's called extending the straight line segment. Yeah. So it doesn't matter what you're standing on when you're holding the ruler, or what the conditions are or whatever.
Yeah,
It
you're just
just
always picking up your
means
line.
if you can pull, you can accurately enough line up that ruler, the edge of it. It's basically a straight edge. But if you can imagine on your wall using a level and getting that bubble in the center and making a horizontal line, straight edge, and then from that point on, don't use the bubble level, just use the straight edge and extend that line all the way around your room. If it comes back and matches up with your beginning point, your first benchmark, that line matches up and makes a horizontal plane all around your room, then you know you're accurate. If you're above it or below it, your error margin is plus or minus whatever that is. It's called closing the loop.
Yep.
So if you do that and you make a horizontal plane, you can stretch a string across your room from line to line. You can measure down from any point of that line to your floor and see if it deviates, or your ceiling and see if it deviates. That's basically what we did. We did it over water to see if to prove that the water was deviating, and it wasn't.
Yeah, but you're saying that like as if like when you extended that line, you had to redo the level like every like 50 feet or 30 feet inside your
No,
room.
not what I
Like
said.
that's what you said
That's
that you had to
not what I
redo
said.
you said you had to redo the level every like at the maximum like your was 500 feet. The furthest you can
I
extend that line.
You can't do both, dude. You
never,
can't do
ever,
both.
ever, ever, ever mentioned 50 feet, and I didn't redo a level line.
I was like,
We,
I was
I've
using your
said more
inside
than
the,
once.
I was
I said
using your
more than
inside,
once
I
that
was
we
using your
extended
inside the room. I was using your inside the
extended
room
the
example.
original horizontal line. Can you
Yeah,
say that one time?
in your experiment, you had to like reestablish the level every few hundred feet.
We
You
had to
told us.
reshoot the original, or the last horizontal plane that we extended. But that's how you extend, just like you move the ruler. And you're going to
So like
have
what?
error margins. Hang on 1 second, because I'll do something that helps you. You will have error margins every time you move the ruler or the measuring tool that establish a horizontal, but it will always be plus or minus.
Yeah, but the point is to like after you go to like your 10th nail or whatever, is to check
Yeah.
it like to back sight your nail number one and then compare it to see if you're getting the same horizontal angle or vertical
Yeah, we did
angle.
that.
Like
Yeah, we
yeah,
did
so
that.
like
But
why
we
do you
don't
get
do that over distance. We
why,
wouldn't
why
never go from beginning to end and check it, because we're smart enough to know you're going to get a plus or minus that's exaggerated or in one direction that's biased. Especially on most, I would say you would get a drop, but not every day. Some days if you shoot from nail one to nail 500 a mile away, some days you're going to get that nail being above the crosshairs on certain conditions. And we know better than that. We make a living using these tools, and 300 feet in Louisiana is about the furthest you'll ever go to shoot elevation of a horizontal plane, like from a benchmark. If you go any longer than that, even over short distances, like 400 or 500 feet, you just get so inaccurate that you probably won't get paid.
yeah, because Earth's curving.
No, because the conditions of the day sometimes will make that benchmark above the crosshair, and that's not Earth curving, sir. That's concave Earth. Hello, crickets. You ever shot a shot where something is above the crosshair where it should be below? If you
The point
haven't,
is
then you
not
haven't
what
been
you're
shooting on it.
the point is that's what you correct refraction for when you like that's what
Okay, well
refraction
we're trying to do shots where we don't have calculations and corrections to be most accurate. First order measurements. That's why we do shorter measurements. That's why I asked you earlier if you think you're more accurate because you're doing a longer measurement, because that means you're not doing a first order measurement, which is inaccurate. And I'm not telling you you're wrong. Like I've taken up for you. I think you're telling the truth of what you're doing. I think if I go out and do zenith angle measurements at, let's say 500-600 feet in my area, I'm going to get excess most of the time, but not all the time. But if I do shorter, more accurate zenith measurements, I'm not going to get any excess, which is going to prove planar Earth. But we can't have that, right? And if I do longer distances, sometimes I'm going to get not excess. I'm going to get the opposite, which would mean concave Earth, and we don't want that either, right? I mean, you seem to want the spherical excess, right? You seem to want all the measurements that prove that you have drop from every location at any distance, but that's just not true, man. I mean, I'm sorry to tell you that. I can go out and take the same measurements you do, use the same formulas and calculations, and get drop 99% of the time, right? Take the average and get pretty close to the Earth's radius if I use the right formulas, right? Doesn't mean at all that the Earth is a sphere. It just means that I did the math correctly. Well, I don't want to do math. I want to do measurements. First order. Horizontal plane over static water as best you can, plus or minus error margin, and measure down to that surface and see what it's doing according to the horizontal plane, which proves shape. Any other mathematical formula or way to prove shape otherwise than what I just stated is inaccurate or not as accurate. So if you're getting concave Earth, I think you're wrong. If you're getting spherical Earth, I think you're wrong. Because when you do it the most accurate, especially at short distances, you're never going to get anything other than planar Earth, which makes the most sense because anytime we go away from that slight deviation of planar Earth and we add water to it, the water flows. Like if we make a slab that's 500 feet long and we set up in the middle so we're only shooting 250 feet at a time, so we're being really accurate with first order measurements, and we make a slab, and we pour concrete and we pour water on top of it, or it rains, and you have this slight deviation of it being lower than the horizontal, it holds water. If you have a slight deviation of it being above the horizontal, that's where it dries first. Or if you fill a swimming pool and you make the coping perfectly horizontal, the water level, when you fill it up, if you fill it all the way to the top of the coping, will show you exactly where your error is. And if it works over short distances, surely it would work over long distances, which means if you had a drop from horizontal, right, from the original benchmark, it drops feet, then water would flow. Water doesn't flow.
You're assuming that water is horizontal in this scenario.
That's all.
Then the channels are Globers.
That's all
So I
presumption.
put a benchmark 1.5 feet above the water, which I thought was curving, and made a horizontal line above it with plus or minus error margin, and then measured down to the water, and it is horizontal. It's not curving. And then when you theoretically think about it, if it was curving, right, it would have to have flow, because that's when we do make a horizontal with the same tools and we deviate, we do a rise over run, deviating from that horizontal, the water will flow. Like even if you just deviated a fraction of an inch. Yeah, sorry. I don't want to wreck people's worldviews, but really what I'm after is truth. I personally go further and say they're hiding the creator by taking creation and basically turning it upside down. But that's my personal belief, right? And where I put my faith, because I can't show you Jesus, but I can show you how to measure water that's not curving. And if you're going to be a surveyor, you can do it too. You just have chosen not to do it so far. But thanks for listening anyway. And it's not just you and I, talking and trying to work it out. It's other people listening and trying to understand. So we try and make it as simple as possible, because surveying is not hard. I mean, that's why it takes 6 or 8 years to get your license. I commend you if you get that, because it is tough. I don't have mine, nor will I ever get it. I hire people for that. I work with them closely. They stamp off on my measurements, right? We use we use the same tools and processes that they do, but we don't have the certificate, right? We didn't go to school for that. So we have to get surveyors to come check our work and then stamp off our as-built or our plans to get inspections, right? But it proves that we're doing the work accurate enough when they put that stamp on there because they're willing to lose our license if we're wrong. I hope that clears it up. You have any questions?
Yeah, what do you do for work that you're using total stations and theodolites?
Construction. We do huge commercial projects and residential, like slab work and driveways, pools, and whatever. But like I
Yeah,
do
but
large scale.
what are you using a total station for specifically?
We usually don't use my total station. I own two total stations. We usually in like slabs and stuff we use laser levels.
What model
Most of
total
the time
station
we're
do you
doing
use?
work at night. Huh?
What model total station?
Oh man, I couldn't tell you. I couldn't even tell you a model of any of my lasers or whatever.
It's right
I'm
on the
not that guy.
machine.
Yeah, well, I'm on a cruise, dude. I mean, I can get it for you if you really need it.
You said they're your personal instruments. So, like, I don't
Yeah,
understand
I
how
have
you.
one in one of my trucks. Yeah,
Yeah, what's it called?
I have
Bro, I
no.
couldn't
I'm
tell
telling
you
you
the.
right now, I have no idea of any of my lasers, theodolites, or total stations. I
What
couldn't tell
programs?
you one model.
What program are you using?
I have no idea.
How do you not
It's
know the
already in
program?
there. And mine doesn't have a
No,
earth curve switch. It only has a refraction switch.
For the data collector, like, which program is your data collector using?
I do not know. I'm just being honest with you, but I will tell you my
How do
total
you not
station
know? You
might have
had to open up the program. How would you not know which program you're using?
well, I open it up probably once a month maybe, but I don't look at what program it is.
But you have to pay for it.
Yeah, my company pays for it. Yeah,
You said it's your personal equipment.
it is the personal total station I use very rarely. We use lasers and theodolites mostly. We use lasers mostly because we're working at night. Like I said, I'm not a surveyor, dude. I just
Yeah, I
use
know,
the
but you
tool.
said you have like the equipment, you use the tool. So in order to use the tool, you have to have software for the programming. So like, I don't understand how you could like use the tool without knowing the program that you're using.
Okay, tell you what, when I get back from vacation, I'll take a picture like you did and send you the program and all that bullshit. I'll turn it on, show my face, and flip you off. Will that help you?
Yeah,
I
it
mean, if
would.
you can't tell I'm being
That
honest
would
here, I don't know.
absolutely help me. That would absolutely help me know which instrument you're using with the software. That would help me. Yes.
Why would that matter? Like I said, it's whatever software doesn't have a earth curve switch, it only has a refraction switch.
Well, how would you don't even know the software, so I don't even understand how you're invoking it's whichever one
I don't
it
know
doesn't
everything
have.
about it and how to use it, like how to do everything with it. I just know how to do specific things with it, which is basically take it out and turn it on, and I don't use it very often. Right now, my crew is using a laser level as we speak. That's what we mostly use because they started work at 2 a.m. this morning, and they're working at night, and lasers are just easier to set up. You can use one man can use it. You know, it's even easier than a theodolite. You don't have to hold a story pole and all that. Well, you can hold the story pole as one unit, one man. I don't even know what brand laser I have. I just
I
bought
don't
one.
understand that because
Yeah.
like construction companies when they have like when they're checking to see like if their foundation is like at the right elevation or that they're digging,
Yeah.
they have like a rod that goes with the laser equipment and it beeps off when you're at the correct elevation. So
Yeah,
like it does
I
have
have that.
another rod. So I don't know
Yeah,
why
I
you
have
would
that.
say it
Story
doesn't do
pole.
that.
Yeah, I have that. I have.
So it does have a rod.
Yeah, the lasers do. I never said
Yes,
it didn't.
you did
I
say
said
it
one
didn't. You
man
said
can
like
use
that's
it.
why we do it at 2 a.m. because the total station requires the rod and the lasers don't. Well, the
I
lasers
did
do.
not. I said it's nighttime usually, so we use lasers a lot because it's easier and one man can use it. What is
Yeah,
your
but you
deal,
said
bro?
because they don't have a rod.
Are you trying to catch me in a gotcha? I can send you 100
I
things
think I
say
already
and be
did when
wrong.
you didn't know the program or the equipment model or anything like that. I
I
think I already
don't. And
caught
I'll
you in the
tell you
gotcha.
again, I don't know it. I don't even know the brand of the laser I just bought a week ago. I just ordered it. Matter of fact, my secretary ordered it. I can get it for you if you want. It's in a yellow case. Not Epson. I don't know. I mean, why would I have to know? I know where the on button is.